This is actually a bit of a thought process and a sort of a discipline. But the outcomes are really good, and we hope to share some of that passion with you tonight. So we've actually got 2 awesome speakers and 1 other additional speaker. But I'll be kicking off the evening, essentially just giving a bit of a lightning talk around what is data mesh, and trying to weave a narrative around data mesh and fairy tales. And you'll have to bear with me, I'm going to try and stitch these things together. Then I've got my colleague, Kunal, who's going to be presenting some more detailed lessons learned from a particular financial service client who went on the data mesh journey. And finally, we're going to roll out this evening with an absolutely amazing talk from David, who is someone. David, there, thank you, David. So we've got 3 talks tonight. We'll probably pace it, we'll probably run 2 talks, have a bit of a break, and then ask David to conclude the evening. Now, before we kick off, I'm going to put Peter on the spot. And I kind of just wanted to acknowledge that Peter does an awful lot of work behind the scenes to get this community together. He does everything. He coordinates, he organizes the Slack community, and he's going above and beyond by helping to organize something called Data Engineering Bites.
Data Bites, yes.
You want a mic?
Yeah, okay. Well, folks, Data Bites, we've got pretty much the most amazing conference venue you can find in Sydney, the Museum of Contemporary Art Australia. Some incredible talks for the day. We've got our keynote, Joe Rees. He's just written a book on the fundamentals of data engineering. So if you're interested in data engineering, perhaps you are being at a meetup here tonight talking about data engineering, that might be a talk that you might be interested in. I actually have on good note that he might be bringing out a few books with him to Sydney, Australia, so you might be able to get yourself a signed copy. So even that might be worth the ticket price. But yes, tickets still on sale. Massive thanks to all of our sponsors, including Thoughtworks, but if I can read them out, Amuda, StreamSets, Confluent, Mantle Brew, DataStax, Neo4j, Snowflake, Fivetran, Databricks, Microsoft Azure, AWS, Imply, DBT Labs, the Reactor, and a few of our other community sponsors, including Skills Matter, who run Yale conferences and the like. So yeah, I mean, I'm sure some of those logos up there are probably tools that you use on a daily basis. What else can I say? Yeah, it's on Thursday, the 29th of September. There's going to be lots of amazing activities in and around the day. Is it time to shut up already about it, Simon?
I've got a question, Peter.
Yes, tell me.
How did you get tickets?
Well, you just scan this QR code. Look at how amazingly technologically advanced we are to have QR codes on our banners. So you just pull out your mobile phone and yeah, this thing takes you to something else other than a COVID app or whatever. So yeah, just go to dataeng.com.au, you've got the speaker lineup, you've got the session lineup, and yeah, just click through the links and you can get a ticket for $199. It's an absolute bargain, folks. You know, you probably won't find a better conference in town for less than perhaps $500 or $1,000. So really do encourage you. Teams put in an incredible amount of work, including Simon. And also all of our speakers. We've got Karen here up the front. She's going to be doing the presentation, and I think Lizzie down the back, she'll be doing one too. So it's just going to be a really great day of data engineering. The speakers that we've got for the conference, they're data engineers just like you and I. So it's just great for us all to get together, have a conference that we all sort of own and are a part of. So thank you so much. Over to you, Simon.
Cool. Thanks, Peter. You can just say that one more.
Yep.
Can everyone hear me okay? Fantastic. So I'm going to spend about 20-25 minutes or so covering off the question that you've always wanted to know. How does Goldilocks relate to the 3 bears of data mesh? Can I get a show of hands? Who's heard of the fairy tale Goldilocks and the 3 bears? So most people, but not everyone. I might have to do a bit of a refresher. This is me. I'm a principal data engineer at Thoughtworks. But you're not here to hear me. you're here to listen to a bit of a fairy tale. Once upon a time, there were 3 bears, and they lived in a beautiful house in the middle of the wilderness. There was a small little bear, a medium-sized bear, and an enormous, great big bear. One day, these 3 bears, they made porridge, and they thought that the porridge was a bit too hot, so they left their porridge in the kitchen and they went out for a bit of a walk. Now, while their porridge was cooling, this little girl, her name was Goldilocks, and she snuck into the house and decided that she was a bit hungry. So she saw the 3 bowls of porridge, walked up to the first bowl and ate it. She went, "Ugh, that bowl of porridge was way too hot," so she didn't like that. Then she walked up to the second bowl of porridge. She tried that. It was way too cold. She didn't like that. Then she walked up to the third bowl of porridge. It was a bowl of porridge owned by the little bear. And she tried it, and it was just the perfect temperature. So she ate it all up. So that's the story of Goldilocks. And sometimes we talk about the Goldilocks zone as being that perfect place in the middle of 2 extremes. And I wanted to introduce the concept of Goldilocks, because when we're talking about successful implementation of data mesh, sometimes we've got to do trade-offs. And sometimes the right answer isn't perfection. It's just being able to understand the trade-offs that get you in that central Goldilocks zone. So what is data mesh? Here is an extremely long definition of data mesh. Data mesh, decentralized social technical approach for managing analytics data at scale. But in short, it's a way of solving a problem, and it's a problem that we probably all see as data practitioners. We want to understand how to introduce essentially a better way of managing our data products. And you can kind of think of that if you are trying to fit data mesh as a description into a tweet-sized message, you might just say it's a set of principles. Essentially, it's microservices for data, but with the design, the management, and the governance to bring it to life and make it work at scale. Now, data mesh is not something you buy, it's not a product, it is something you do in combination with humans, with people. So it is a process as well as an architecture with a number of principles. Now, this all sounds good, but not every path is successful. And we've had the opportunity to work with a number of clients, both locally in Australia and globally, who've gone on a data mesh journey. And I kind of wanted to share some of our learnings on the way. So essentially sharing some mistakes so you can avoid them. And also hopefully giving you a bit of a sense about what are some of the necessary trade-offs to make data mesh a success. Now, data mesh isn't owned by anyone, but the thinking, the philosophy actually came from Zhamak Dehghani. I hope I pronounced her name correctly. And she wrote this fantastic book about data mesh. But she's also a great advocate for education and sharing, and a lot of this thinking and philosophy is out there in the public domain. So it's a great book, but you don't need to read the book to really get a sense of what the driving principles are behind data mesh. And it's no secret, there's essentially 4 pillars of data mesh. We'll be speaking to that a little bit later, but in short, distributed domain architecture. That's ensuring that data is managed close to its source, close to its origin, because people who produce data generally know the most about that data. And it's also an organizational construct. The folks who are generating data, producing data, are going to be close to it and going to be close to the ownership of it. Also comes up with a second characteristic, data as a product. And David's going to be speaking a bit more to this later. But in short, it's domain and ownership really sort of wraps it up in a sort of a definitions area, so you can actually describe the characteristics of the data. This is all great and philosophical, but this only comes to life if you've got the infrastructure that supports it. So self-service capabilities to both find and discover and use and manage the data. And lastly, this can't be a free-for-all. We need to talk about how do you get the trade-offs between a centralized governance approach, which is going to be a bit slow, and a free-for-all where everyone's doing their own thing. So the philosophy here is how to federate out guardrails, federated data governance. So those are the 4 characteristics of data mesh. Now, you're all a technical audience. So let's jump to an implementation. This is a slightly stylized version of a data mesh deployment at a, just think of it as a Netflix clone. This is an entertainment industry who embrace data mesh. So what does this mean? Well, you can think about, hopefully the colors come out here. You can kind of think about some of these characteristics like self-service deployment and a single view of the customer and addressable audiences. These are like outward-facing concerns that an entire organization is getting to care about. Obviously, you've got the guardrails around governance and compliance that comes up in pink. But when we're talking about, well, what are the data products? What are the characteristics? Give me examples. Those are sort of the hexagons to the left. So customer 360, behavior data, consent management, audience segmentation. All of those things you can describe. You can put your arms around and think, well, that's a data product. And we'll get into what that actually means. So I'm kind of like describing the pillars of the data mesh, but in the, well, what's in it for me, why do I care? The things on the right are why you care. These are what a business cares about. This is how you sell something. This is how you make revenue. This is how you protect an organization. This is stuff that, in a sort of an Netflix equivalent, these are things that you would actually be solving for. You want a addressable audience. You want personalization. You want recommendation engines. So you consider these as use cases on the right. So hopefully this gives you a bit of a mental anchor when we're talking about data products and guardrails and use cases. Hopefully this gives you a bit of a mental anchor for what we're talking about. So if that's the end point, well, what's the path that's going to take us there? And what are some of the things that are going to trip us up? So I'm going to take you through, in a high level, 3 things that we've kind of discovered as sort of false starts or signals that things are going wrong with the data mesh deployment. And the first one is pretty simple. It's kind of just an observation that there were 4 principles. You didn't follow all 4. So it's a bit of a realization that as we've sort of gone through and worked with a number of organizations, we've kind of like had the opportunity to do a bit of a retrospective on, well, what was the path of adoption? And this is super stylized, but you can imagine that each of these lines represents a particular customer and a particular deployment. And just to sort of orientate you here, the vertical axis, the up and down axis, really talks about the tools and technology. So some organizations, like the one on the left, the sort of the brown line, they went really, really heavily on tools and technology. And other organizations went the other approach. They started focusing on use cases and domains, and that's what the horizontal axis represents. And the companies on the bottom right, the companies that kind of went all out on let's find data domains and let's come up with a whole different suite of data products. And they kind of went on that trajectory. And then we've kind of got companies that went sort of on a path down the middle. So I would say in the Goldilocks parlance that if you get just worried about tools and technology, that's kind of like the porridge that's a bit too hot. If you went down the path of understanding all of the possible data products and data domains, that's kind of like the porridge that's a bit too cold. Can anyone guess what's about to come up here? We'll get to that. So ultimately, we need to talk about these pillars of data mesh in concert with one another. So these things aren't in isolation. We do need to care about both the overlap between these pillars. So if I talk about some of the things that we've learned on these previous clients, the one that we kind of tracked on the orange one, that was a really technically interesting deployment, but there seemed to be a bit of a problem when they kind of started trying to integrate the business, because it was essentially a bit too late. And it was kind of like, why would I care as far as the business is concerned? So I kind of had to take a bit of a steer and then started looping in the business. The couple of use cases sort of towards the bottom, which went kind of wide and started on many, many data products, they also sort of got a bit of a slow start because they had all of the buy-in and all the business appetite, but there was a bit of a gap between the technology and the deployment maturity. So the ones that sort of have been the most successful across our recent deployments are the ones that sort of tried to navigate a central path of building the technology at the right pace, but also being suitably ambitious, but not overly ambitious when it comes to identifying the data products. And so in our Goldilocks analogy, we're talking about something that's just right, just in the middle. So that was the first learning, was just make sure that you've got sort of an approach that's appropriate. The second observation, my second there, is making sure that we've got the right level of inclusion across an organization. So we're going to be describing a data product a few times, and it's probably worth coming up with just like a mental model of what's a data product. And if you've ever used an online shopping service, you've kind of got a bit of a sense about, well, what would a data product look like if it was sold by Amazon? These are the characteristics that we want from our data product. It's going to be self-describing, it's going to be discoverable, it's addressable, it's trustworthy. And with those characteristics, we can kind of find a bit of an analogy when we do online shopping. A data product that happened to be a fairly ugly orange shirt is really, really discoverable. You can search for it. You can describe it because it's got all of the characteristics of where it was made and the colors and the blend and the washing characteristics. That's all very, very visible. It's addressable because we've got a way of describing it and finding it and talking about it in business jargon. And is it trustworthy? Well, trustworthy is sort of a bit of a scale, but you can work out if it's active, if it's used, its lineage, its origin, its owner, by having some sort of trust score. So these are kind of like, if you're thinking about a mental anchor around the characteristics of the data product, this is a good thing to use because you've already, it's kind of like if Amazon sold data, this is what it would look like. So here is one that we produced earlier. This is actually a slightly sanitized version of a distributed data governance that we deployed at a bank. And these are the kind of characteristics that you can imagine anyone in the data profession cares about. We need cataloging, we need data quality metrics, we need a level of data ownership, and obviously there's cool tools that allow us to enable it, but these are the outcomes we ultimately care about. These are the attributes of our data set. So when we were talking about federated governance, these are the outcomes of federated data governance. So here's like, again, a slightly sanitized version for something that we did earlier. That same mental model of, well, what's the Amazon experience for a data product within a financial services organization? This is what it looks like. This is discoverable, it's trustworthy, it's addressable, it's self-describing. It's got those same characteristics. And you got there because you ended up with sufficient, necessary, but not overly applied data governance. So I'd say just enough centralized governance and just enough controls around a financial services product. So very, very lastly, and then I'll open the floor, is the path of implementation considerations. And this is kind of like, well, if we're sold on the journey, what does the journey look like? Who do you get involved? And this is kind of very much the consultant's answer of it depends, but we've kind of seen various approaches for adoption of data meshes. And I don't want to say any of these are right, I don't want to say any of them are wrong. I just kind of wanted to essentially lift up some of the observations, some of the trade-offs. So the first approach is a top-down approach. Now this is very much when you've got an exec, quite a senior exec, or a mission statement, or a group executive who really is quite brought in to the data mesh journey. So this is very much the top-down. This is led from the top. This is undisputable. It's going to be a mission and an outcome on behalf of an organization. So top-down approach works, don't get me wrong. So the advantages here is it's obviously clear to everyone. It's going to be a corporate vision. You're going to have some milestones and some stage gates, and it's obviously an organizational change that's going to be rolled out. So if you can imagine a huge enterprise declaring we're going data mesh, this is a top-down approach. The considerations with that approach is obviously you're going to have a large organizational impact. If you're a huge multinational, you're going to have to do large amounts of change management all at the same time. It's obviously a big commitment, and you need a level of organizational maturity and organizational stability to lift this stuff up and make it a top-down approach to data mesh. So what's another approach? Well, another approach is to do a bottom-up A bottom-up is obviously localized. It might be a team unit, it might be a division, it might be a localized team that thinks, okay, we're going to go on a data mesh journey. Again, this isn't right, it isn't wrong, but there are trade-offs with this approach. The advantages here is you get to learn things, you get to move quickly. You can start with a slightly more nebulous or organically growing organization, which is great at those barriers to start. But maybe some of the considerations for a bottom-up approach to embracing a data mesh is it's going to be difficult to scale. You might get moving, but it might slow down over time. It can be difficult to engage leaders, and you can think about this as it becomes a bit of a longer roadmap because you've got to start thinking about how you're going to organically grow your data mesh across other business units or divisions or however the organization is structured. Again, not right, not wrong, but some of the considerations for a bottom-up approach. So the middle approach here is essentially a hybrid of those two approaches. It's neither top-down or bottom-up. And this is where you kind of want to embrace from an organizational direction, which is clear, but have a level of autonomy with each division or business unit or whatever it happens to be. And this gives you, again, advantages and disadvantages, but it feels like somewhere in the middle and a better of most worlds where you can move faster, you can show results sooner, which is super important, at the expense of it can be a little bit more complicated with program manager, program management, and some of the adoption slows down over time. So that was a bit of a lightning tour, and this was a bit of just a quick diagnosis of some of the things that we've observed while deploying numerous but non-specific data mesh deployments. So I kind of just wanted to summarize this just to have a bit of a takeaway. First one, adopt all 4 pillars. Don't cherry pick, don't over-index on one or the other. Embrace them all, they're all interconnected. Include everyone. Appreciate the needs of an organization. Appreciate there's always going to be trade-offs, but you do need to at least inform everyone and have a level of awareness around that data mesh journey. And have a consideration of the appropriate approach. Again, there's top-down, there's bottom-up, but ultimately you want to think about a level of confidence around your approach going forwards, and showing results is super important as you go. And with that, I just wanted to say thank you, and I hope you have enjoyed the fairy tale. It's a fairy tale indeed. Any questions?
Yes, I'll just grab the mic real quick.
But we have a microphone and we want to play with our toy.
Hello.
Hello.
Just wanted to ask for this, what you just said, how this is going to be aligned with the enterprise digital transformation journey. Thank you.
Okay. So the question is, how does data mesh interact with a, what's the phrase used?
How does it align?
Yeah. So I'd say that this is complementary. At the end of the day, you're solving for data, which helps and assists on a data transformation journey, but it isn't the data transformation journey. So if your organization has an agenda to grow, to scale, to modernize, those are good things. This could support it, but it doesn't replace a data transformation journey.
Yeah.
Does it?
Yeah, can I just add on to that?
Oh,
So
please.
an enterprise sort of vision, right, isn't complete without embedding a data aspect to it. So we can't holistically say we're delivering an enterprise vision, an enterprise solution without having strategies in place to address data needs. And thankfully, modern enterprises, and even the very big ones, typical financials, are beginning to also put that into consideration. Now, and the pathway towards data mesh, has come onto the table as an option, that an enterprise can actually embed into the, overarching vision to then move the organization, forward collectively. So yes, it complements, in fact, every enterprise, framework, every enterprise architecture should be looking at options, for advancing their data maturity, and they can't look at it, in isolation. Otherwise, the whole thing doesn't matter.
Cool. Thank you. I like David's answer. That was very good. Got a question over here.
Darius, I'll grab your seat.
I just have a quick question. Do we have any products on the markets which could help us with data mesh? Like, you know what I mean?
Okay.
Software products, basically.
This is such a good question. Are there any products on the market? No. Sorry, I'm going to step into dangerous rambling in a moment. There is no such thing as a data mesh you can buy. A data mesh is an architecture and a culture and a lot of organizational concerns wrapped up on behalf of a business. So it's hard work. It's like trying to buy fitness. You can't buy it. You do actually have to put the hard work in. You can buy the exercise bike, you can buy the gym membership, but you still have to go to the gym. Sorry, that was a long way of saying there isn't a product. No. There are opinions. There are definitely opinions and opinionated approaches to help you on your way. But if anyone is trying to send you something that promises you data mesh after signing a check, I'd say there's a moment of disappointment at the end there.
You're starting to sound like Scott Bellamy. Simon.
Okay.
Or it's like one DevOps, please.
Okay. I don't want to. I want to make sure that there's enough room for the other.
I'll just add on to what Simon said. So yes, there are not really out-of-the-box products which you could just take and then you basically get started. But there is a bit of traction around some of the cloud providers started giving out some of the frameworks on their own cloud platforms, which will help you to, when you go deep down the code and then start creating those entities around producers, consumers, etc. But again, they are just there to help you, but not really solve the architectural problem which you have to care about. And then it's also about a lot of it's about people as well. In terms of collaboration, there's a lot of shift of responsibilities which you have to sort out. So just adding on to that.
Awesome. Thanks, Simon.
Yep. Thank you everyone for listening, and we're just going to do a very, very quick change and ask Kunal to come up. So thanks very much for your time.
Quick reminder, get your tickets before you leave. We're going to be checking that everyone's got their tickets before they leave tonight. But yes, Data Eng's prize. It's going to be amazing.
Peter, you should stick one ticket under the chair.
That's what I should have done, right? Yeah. Solved all the problems. So good. That's it. Yeah, Santa won't come to visit unless you put out Data Eng's prize tickets, right?
Chocolate bar.
Data Eng's prize 6 fills right out. That's good.
Hello.
Kunal.
Can you all hear me well? Thank you. All right, thank you, Simon. That was a great talk, and you've made my life easier for my talk. So, hello everyone. I'm Kunal, lead data engineer at Thoughtworks in the Sydney office, and I've worked on in my data journey so far around data products, machine learning products in various industries, primarily retail, banking, and internet publishing. And in my talk, I'll go a little bit deep down on a specific data mesh implementation that we did at a local fintech company, and some of the lessons that we learned on the way. By no means these are the things that all things that could possibly go wrong. There are so many other things which you'll find out when you sort of start in your own journey. So with that, let's get started. Cool. So a bit of the organization context. So this organization, as I said, was a local fintech company, established sort of a scale-up mode. It was not a point where they're just starting with their data journey. They had invested in data, fairly modern technology stack on their data architecture. And they had quite a bit of external data sets apart from a lot of internal data that they were generating, and a variety of use cases to solve. So when we stepped in, we started looking at what sort of data landscape that they have and what were broadly the challenges that we found there. And we could basically categorize them into two. One was broadly under the data engineering practices that they had, and the second one was more around culture. The culture was the harder bit to solve. On the data engineering practices, some of the things that we found, production pipelines running in notebooks, non-reproducible infrastructure, whether it was governance or whether it was data pipelines or any service on their cloud infrastructure, none of it could be reproduced very easily. There were no tests in most cases, or there were very little flaky tests, which weren't really helping a lot. So sometimes it would take data engineers to sort of take hours to find a metric bug that they were reported by the stakeholders, and to fix it and then finally put the change to production would be really long from the time it was reported. No surprise, lack of a strong data governance process wasn't there, so people would just go and modify things in the UI instead of raising a pull request through infrastructure as code to make a governance change, policies or permissioning, whether it be storage or orchestration services or any of that. Coming to the culture bit, some of the things that we saw were like no clear data ownership. So you couldn't really tell who has actually done what, who is responsible for what, and it would be like chasing people when you had to find out something about a pipeline and the metrics if a decision had to be taken. And so was the case if something was broken. There was no data product mindset. There was no trust on the data produced by these teams, by the stakeholders, and they would probably find workarounds that I'll pull this number from somewhere. I don't even care about what you're producing from the pipeline because I'm not sure if it's correct. And then finally, the biggest one was that the data function was treated very separate from the rest of the engineering. So it wasn't sort of the same focus and seriousness that they would have on the as they would have on their core engineering practices. So that was that. Moving on. So as you can see, a lot of these problems that we found there could have been solved with a data mesh adoption, which Simon has already covered. So there were a lot of people and technology problems, not only technology problems. So we started off identifying what their business functions were, how could we map data products in a very cohesive way into those domains, and then say that, okay, this is making sense, this is a decent cross-functional team to work on this data product. And these were primarily their functions that we could see, like marketing, finance, risk, product, and a few others. But core functions who would use data for their day-to-day decision making, these were the ones that we could see there. So with that done, the next thing was to identify where do we start? What is the first data product that we should go with? And how do we sort of get started? Because you can't really start with multiple products at the same go. You want to start somewhere, prove that, and then move on to the next, and then give them a framework that they can build upon. So with some brainstorming sessions with the stakeholders and inputs from them, we started looking at all the functions, and we identified the first product to be a marketing use case, which was basically a data product to identify risky customers. And the idea was to not pitch a finance product to them. And the business outcome that was desired was basically not have bad debts. Because if you know in some way that these are the customers who are likely to not pay back in time or bad debt, you don't want to pitch them proactively. So normally this would be done by their risk team. They would pull data sources, run some ML models, and basically find a way to say that, okay, these are the list of customers. Don't pitch any product to them. So the idea of this product was to first avoid all that manual work, and then secondly, obviously, to basically prove that this is how a data product is built on your data mesh journey. So how did we get started? So as Thoughtworks philosophy, we always start with a thin slice approach. So that's what that triangle is telling you. That always build something which is usable. Cut across all the components while building anything. So at the end of the day, you're not just producing a platform which does not solve any business use case or a business use case where there is nothing reusable. So that was our approach. So with that, we also made a start towards the self-serve and integrated platform capability, which Simon touched in his talk. That initiated federated governance via infrastructure as code, where you could have a central repository with all the infrastructure code, and then you could continue extending that as you're onboarding new data products. And all of this was domain agnostic. So any federated governance that we were building was domain agnostic, so that you could bring on your second product, third data product, and still use the same infrastructure. Besides this, we also believe in uplifting core engineering. So it was not only about showing data mesh adoption, it was also about finding all these issues that we saw generally around their data engineering capability. So like lack of tests, repeatable infrastructure, automated deployments, and so forth. So when we paired with the data engineers on the team, we also uplifted those capabilities as we sort of went building features. So what were those things? So front-based development, test-driven development, doing tests at various levels, so unit, integration, scale, all of that. And then finally, it was also important to showcase progress to the stakeholders, because if you're in your own world building something which nobody knows about, that is not really going to give you any confidence, especially to your stakeholders, so that they can keep investing in building data products and continue supporting you on this journey. So yeah, that was basically how we started towards it. And we work in typically time-box sprints, typically 2 weeks. And after about 6-7 sprints, we had this production-ready first product, went to production. And basically, at that point, marketing did have to do a lot of manual work. Data pipelines started flowing all those bad customers into the system. The campaigns would pick them up and only pitch them with high confidence that these are the right customers to pitch the products. So, segueing into how did it all go to this point? Like, did all go well? Well, not really. There were moments of highs and there were moments of lows. There were moments where we felt like we were really doing well, and there were times where we were not sure if we're doing well or not. And we would get hard questions with in the showcases and so forth. So I want to segue from this slide onwards to talk about some of the lessons that we learned on the way. Some of them are technical, some of them are non-technical lessons. So lesson number 1 was, when you're choosing your first data product, while I can't give you a formula, but these are the 2 things to keep in mind. It should be a function of business value proposition and the number of dependencies that you have on the moving systems, and also people or the teams involved. Basically, you have to tie it back to the sources that you're dealing with to build that product. So what that means is something which has a very high business value, which people care about. Like, if you build a pipeline and produce these metrics, would people be interested? Are people looking forward to that to make decisions? And then secondly, identify something with a low number of dependencies so that you don't get stuck up and the complexity is not super high. In our case, I think we could have chosen a better use case, which was around a risk product, because that was something which was really more important, and we realized that quite late in the game. So that was lesson 1. Lesson 2 was more around executive support. This was probably one of the biggest lessons, I think. What this means is, as you could have realized from the talk that Sam gave, that there is a lot of people support required, and especially from your C-level executives, especially from like somebody like a head of data or who is representative of your data function, and they need to back you from the start. You need to buy in to this data mesh adoption and understand what it means, why we should do it, and they shouldn't really be doubtful on this, because that is going to fail toward the end. They will start backing out, or they will not really give you the support all the way along in this journey. And that was pretty much the case in our situation that we are talking about here, where the head of data came in a bit late. A lot of critical decisions were taken, and he did not really have a full understanding of things. So that sort of started fading out, and it even got to a point where they started building towards a second data product, which was more important to build because the stakeholders really wanted it. And then that also did not go too well. They were, it was a single person team, and it got to a point where, business said that either give it to us in a week or we don't even care about it anymore. So this was probably one of the very, very important lessons. Accountability and OKRs. So this was again a technical lesson that we learned. So when we build a data producer pipeline, because one of the principles is to let a team around a source system be in control of that ingestion pipeline, so that there are issues, they can go and fix at the source. We did a good job of that, but what we should have done quite early on is to basically define OKRs and SLOs around it. So very quickly we realized that if there were production incidents because of some schema issues, mostly schema issues, we wouldn't really see people. Sorry.
Can you please define the acronyms? OKR and SLO.
Yes, or objective key results and service level operations. So yes, basically they didn't really stay on top of it, and we had to sort of chase them and ask them, could you please look into this? And we had to sort of give our support to them to be able to fix things, which meant basically that they had this they weren't sure whether we should jump onto it or not. What's the time by which we should fix and move the change to production and things like that. So that was the other learning. The next one was around something around the data checks that we built. So any schema checks that were failing, there were occasions where there would be some critical P1 failures where something would be broken and the pipeline wouldn't run. And there would be changes where, because the source teams would also do ongoing development, there may be columns or things like that that are introduced which you don't really care about because you don't use it in your data product pipeline. So we could have done a better job of sort of isolating the quality check failure, like what is an alert, what is a P1 failure where you need to be alerted. How could you split it out into environment-based alerts so that it's less noisy and there are not much distractions. Lesson 5 was around pairing with infrastructure. So we received a bit of pushback when we started off working with the infrastructure team, and there wasn't really much buying for an infrastructure person to work in a data platform capacity. So that came in a bit late in the game, but it would have been helpful if they had been there from the start, because you want to basically keep a key metric when creating self-serve infrastructure as how soon can you launch the second product without really doing much, because you would have created a lot of reusable components in your first product anyway. And finally, on the onboarding of a data producer, we found that there would be occasions where a data producer team would not really know how to basically go about fixing a failure, where to find their CI/CD pipelines, which is the schema registry where they should look at to make a change, promote a fix, and then how to test it in a non-prod environment, and then finally deploy to production. So we did that. Again, could have been done much earlier in the game, so that you could basically make it very easy for them to sort of find what is where. So just to recap, whenever you're starting, I think from all these lessons, what we are basically saying is address both people and technology problems. It's not only technology, it's not only people. You have to balance out both. Communicate well. There's a lot of communication involved. I remember going into a lot of chats with data producers to make them understand, the SLOs, that we expect them to sort of get going once they are alerted with a failure and not really wait for anyone. Where to look for tracing their CI/CD pipelines, how to test and push a change, etc. And finally, the last point was any data producer team that you're basically interacting with, set the infrastructure well, make it very clear to them what is expected from them, and do everything basically to make them successful. And that is all I have. Any questions?
Awesome. Just that round of applause for Kunal.
Hi, thanks for the presentation. In your experience, is there a specific or other specific industries or sectors that could benefit the most from this kind of architecture?
So the question is, are there any specific industries that could benefit from a data mesh philosophy?
Yeah.
Don't think so. I think it's mostly, there are certain prerequisites that you should take, whether to sort of ascertain whether it's a good fit as an architecture pattern or not. I doubt if industry is one of the things to look at, but I would say mostly the organizational maturity. Do you have that many disparate data sources? Do you have enough number of data engineers to work on your pipelines? And what's the technology exposure or the technology capability that in the company would be mainly the factors to look at.
Can I just do a bit of an add-on to that? There's probably a reverse answer of data mesh is not appropriate if you're a small startup, if you've got a simple use case, if you've got just our database and a GUI put on top of it. So there might be things that it's just not worth it, or you don't have those problems to solve. So kind of answering the reverse of it, if you're a two-person team or just building an HR app on top of the database, maybe it's not appropriate.
Good question. Occasionally I've got intelligent questions. The one thing that I really struggle with data mesh with is that you can convince the data sources, like say, for instance, the microservices team, to actually shape the domain data in the way that's useful for a data product. How do you go about doing those conversations with the producers?
Yeah, so in our case, it wasn't really too much on the shape of data. I think what all we wanted from them was ingest it from the raw sources and land it in the raw zone. So as typically in a data lake architecture, you have like a silver, bronze, gold, or raw transformed gold, or business zones. So all we wanted to for them to do was to basically make sure that ingestions on whatever your ingestion frequency is, make sure that data lands with all the checks passing. And if there is a check broken, just go and fix the check. But from that point onwards, for our use cases, we would take care of all the transformations and data modeling and onwards from there.
Gotcha.
Cheers, Peter. It's kind of a follow-up from that, and it was something that we actually worked with Thoughtworks on and carry on at West Farms is the step above that, the business units have, and it's not just the data mesh, but the data, the data-driven design. How do you get business units that are already pre-existing or kind of call the shots, let's say, to align behind domains that then the technology team defines that they might not necessarily agree with? Like marketing, for example, at West Farms, we defined multiple domains within marketing. It wasn't just one big, monolithic kind of thing. But the marketing team that then called the shot weren't able to get behind what we define that as. And just kind of thinking in terms of like the Spotify's and Netflix as well, that define themselves by maybe technology first and whatever second that might work for. But like the banks and telcos who are business kind of first and technology, how do you then get them to come on board with how you define domains that they might not necessarily agree with?
Yeah, so you're talking about a case where you have a quite a large function and then there are like sub functions under that. Is that what
exactly. So
yeah.
But the technology team's trying to break down the sub functions, and the actual marketing team might, as a business unit, might not agree with what technology is saying. So then to align the products behind it, let's say in the mesh, and that might be difficult.
Yeah, I think it is challenging when it's a large business function with a lot of sub functions. But what you have to look at is what is a cohesive domain. So for example, just to take a hypothetical example of Netflix, for example, if you're creating a churn prediction data product, what you would look at is what are the teams that are pushing data and what you care about, and then work backwards and then see like what are the producer teams. And basically you have to work backwards, like identify your product and then work backward towards who are the producers, which systems are basically producing the data, and then sort of start identifying the teams to form around it. So it has to be a bit cohesive, but then independent enough to form a product around it. Does that answer your question?
Like, but if you get, if like I get what you're saying, if you work backwards and then all of a sudden you get to the point where the actual marketers don't, like someone that you've just formed that product around doesn't agree that that's their, how they define themselves as a product or as a domain, whatever, how do you then reconcile those two, the technology and the business team?
I think you can, because you basically would look at, because in the technology side of things, it's easier to solve it because you basically are looking at forming a cross-functional team. When it comes to a business function, all you need from them is like a domain owner. And then the domain owner is mapped to a data product. So it's not really too much of a question of how marketing teams form. It's more a question of what product are you building, and then identifying a domain owner for that, and then taking the domain owner from whichever sub-function that person is from.
Did you want to add to it, Karen?
Yeah, is there
The microphone, so we'll come back to you, buddy.
I'll try to memorize my.
But it started a great talk, Kunal, about it's generating so much discussion. Pretty good.
Thank you. So I think if I understand your question correctly, it's like, how do you, if you don't want, or domains don't want to come along the data mesh journey, or you define, is that true? Like it's more around
The people that aren't technical don't agree with, maybe don't agree with how the technology teams are defined those domains,
yeah. And I think it might be, like one of the things that we kind of talk about data mesh is the socio-technical paradigm shift. And we had this conversation earlier where it's like the questions that you have to answer are difficult to answer, like having domain ownership. It's not just a technical, like it's not just a technical teams who should be defining that. It should be alongside those domains from the beginning, and having those really upfront kind of difficult conversations and leaning into it a little bit. And it shouldn't be like driven from one place or the other, but more kind of a collaboration. Yes. I understand that can be difficult in some organizations where there may not be very high data, like understanding of data or data literacy, or data may not be kind of in the strategy for that org. So it's kind of like, to Simon's point and Simon's topic, it's like you've got to go bottom up and top down a little bit. So you do need some executives who have, who understand the vision and are willing to kind of push that a little bit at the same time. Because it really should be the technical teams and the kind of the business and the organization who are working together. If it's just driven from one space, you probably run into difficulties like you just described. Does that help?
Yeah, absolutely.
Awesome. Thanks, Karen. Just one last one, and then we'll break for a slice of pizza. Sorry about that one.
Oh, that's fine. I'll try to keep it short. I had a few questions, and I'm just going to keep it at one. Is there not two small questions? Considering this use case, is there anything? Is there a specific role, like a specific role that is very important that has become apparent throughout this process? Because oftentimes in these big projects, people tend to underestimate, like at the beginning, you need someone from the executive side and some techies, but there's something in between there. Have you had any of these types of experiences, and is there a specific role you would like to point out?
Okay, so just to make sure I understand your question, was there any specific role that was more like that stood out more, like in the journey that we felt like this role is really critical?
Yes, exactly.
Yeah, cool. In our experience, we found DevOps or infrastructure team was critical because generally they are most in demand in any organization. They are quite cross-functional. Everyone has a need or dependency on DevOps. So that was a big challenge to sort of have a buy-in or basically the dedicated time to build those self-serve infrastructure.
All right. And is there also a role for somebody to govern the process of the whole data mesh architecture, or is that not part of it?
I would say that was something where I feel like your head of data or the C-level executive support is required, and that person can drive a lot of that adoption, because it might be a case where your first data product pays the pioneer tax, and people may get bogged down, that it takes so long, and then you start deviating, or as Sam covered, as the first issue of you start deviating and then you don't abide to all the principles. So I think that role, I would say, is critical to make sure that you sort of are consistently going along and feel that you're going in the right track.
So it is important to have someone that governs the process.
Yeah.
Okay. Thanks.
Well, a round of applause for Kunal. We're just going to have a quick 5-minute break, grab a slice of pizza, grab a top up or a bathroom break, and then we'll dive straight into David's talk. I think he's got an awesome one, so in for a real treat tonight. So thanks for hanging around. Cheers.
Choose your company, man. I grabbed the book.
Hey everyone, we're going to get underway pretty soon. David's going to kick off. If you want to grab a glass drink and grab a seat, we'll get underway. I think, Simon, we're going to hang around for a couple of hours after the talk. So plenty of time for networking after David's talk. Awesome.
Yeah.
So we'll talk about Thoughtworks. Data products, data mesh. Awesome. All right.
Everyone here is ready? Thank you so much, guys. It's good to be back. Having face-to-face, meetups. It's absolutely fabulous to get to meet a whole lot of, old faces, old folks, and talk about data mesh. Now, thanks also to Pete and Simon for the opportunity to come have a chat. I actually thought, Simon did a very good presentation by laying the foundation around data mesh. And what I'm going to do tonight is just to build on top of that. Now, so my name is David Ndukwu. So I've been around doing stuff in the big data space, for quite a while. Now, so what I'm going to be talking about is, again, some of the lessons learned in our attempt to try to bring, the concept of data mesh, alive. So before getting into the crux of this, conversation, I just want to quickly lend my own 2 cents around this whole concept of data mesh. Now, it's become the buzzword. Everyone wants to talk about it. If you're not doing data mesh, it feels like you're being left out of the party, isn't it? Like I see a lot of people being eager to say, hey, how do I implement data mesh? Now, so one of the things I tend to do is to run some independent consultancy, services for small businesses. And oftentimes when I get into those environments, the first question that they put to me is, how do I build a data mesh? And I'm always very careful with giving responses. What I would say, typically tell them to hold on. Let me have a look at your environment, your existing landscape, and see where you are in terms of the level of maturity. And then we can talk about whether or not a data mesh is good for, is a good fit for the business, or not. All right. Now, can I also say, and with all due respect to Zamak, who's not here tonight, that the concept of data mesh, or what we've now come to know as data mesh, is actually not entirely new. It's been around for a while. Now, for those of us who played around with the big financial services, be it insurance or banking, you go in there, there's a massive proliferation of systems, from the mainframe systems, they then moved on to big legacy systems, transitioning into, data warehouses. Somehow they found themselves, building data lakes, and then that transition again into lake houses, and then today it's all, data mesh. But the good thing that Zamak has done, which I do appreciate all of that effort, is, being able to explain what all of that means. And data mesh, in our own terms, is the perfect way to explain all of that. There's disparate, data sources. They are sort of pseudo domains who have always built our data products over the years, but they never had an understanding that they were actually building our data products, or they never had an understanding that they actually fit the, so to say. But thankfully, Zamak has then come in. She's written a fantastic book. In fact, I actually read her book after we finished this project I'm going to be talking about, and everything, pretty much everything she said in her book, really resonated nicely. And I can also, pretty much align with all of the, great concepts that, Simon had pitched in, earlier on. So this all makes sense. It all makes sense. So it's not entirely new, but great work to Zamak, for all of that. So if you're here and your intention of perhaps of coming here is to find out how to turn my organization into a data mesh, please just be careful before you mesh things up. Take it easy. All right. Data mesh is not the holy grail. It's not the one solution that fits all. You need to have a perfect use case for it before you go down, a rabbit hole. All right. Now, can I also say that one of the things that a data mesh enables is a data product, like Simon has mentioned earlier on. Data product is the in thing these days. Data has evolved. The way we understood data over time has evolved from looking at data as a strategic asset, to then looking at how we monetize data. And also, a data product is one of those avenues that gives you an opportunity to actually commercialize your data assets. All right, have a strategic objective or viewpoint, that talks to a vision around the data, and you're able to make some good bucks, out of that data. Now, when you have all of these, great concepts coming together nicely, then perhaps your data solutions are beginning to bear much semblance to a data product. Now, I used to work, for a financial services firm that built out insurance product. I'm sure everyone here has got insurance in one capacity, one way or the other. Either on your mortgage, you've got insurance tied to it. Your car, you've got insurance tied to it. And then insurance, business actually sells you this product. So when you walk into a broker to buy a typical insurance product, essentially what you're doing is actually interacting with all the various domains that make up that insurance product. All right, an insurance product doesn't just live in isolation. There are fabrics, there are components, there are foundations that make up an insurance product. And when you look at a typical insurance product, you have components like a claim, you have your policy, and you also have your location details and also your customer details and all whatnot. So there could be many more components, that come together nicely and they distill into an insurance product. All right, so I'm not an insurance expert. I'm not going to dwell into what these things are. But it's very important that before you then go ahead to identify what your product is, right, or what your domains are. So when you look at all of these components, they can actually be treated as domains on their own. They actually self-isolated, are part of the business, building out reusable components that will then eventually become part of the data product. All right. Now, someone did ask a question earlier on as to how do I know that a domain is actually a domain? And this is one of the very intricate questions that people should ask themselves, particularly if you are tending towards the part of a data mesh. Don't just create a domain because you want to create a domain. You need to look at the product holistically and say, Kai, this is this product. Now, what are the foundations? What is the make of this product? Now, and it's important that when you are identifying the domain, your domains have to be idempotent in nature. The domains must not crisscross. A claims domain must not crisscross with the policy domain. The policy domain must not crisscross with the location domain. And the location domain must not crisscross, the customer domain. But if you do find evidences within your domain construct or your domain definition where there are crisscrosses, it probably means that you're doing things wrong. And that is why it's important to have a clear product vision, someone who understands the product, and also being able to own the evolution of that product. Every real product must have a product owner who understands how the domains, will need to come together to create that product, the various interdependencies. And then that person is going to be, a part of a committee of a governance forum or structure that is able to align, how the domains evolve and also how they contribute to the product eventually. All right. So this is very important before we go in and start creating pseudo domains. Okay. So when so for me, I'm gonna focus more on the engineering aspect in terms of when we deliver products, what does it mean? So we got a few years ago with the team, and we looked at the system, and these guys have been shipping out insurance product for so many years. But when you look, under the covers and find out how these products been shipped out, you tend to realize that all of these domains are actually running to each other's ways. Now they're using a single monolithic pipeline architecture that ensures that they build that product. So over the years, there has been success in building that product, but the problem arises when you then need to scale the product. Now we have instances, for example, where the domains will run into each other's ways, and the domain, a typical domain, goes in and blocks the pipeline, and that means the entire business, the entire stream is shut. Nobody goes forward and nobody goes backward. So you don't want to do that. All right. So this sort of monolithic pipeline creates a whole lot of bottleneck in a domain, in a pipeline architecture. So you can't scale your domain, you can't scale your product delivery if you don't start thinking about a pipeline architecture that supports the scale and the evolution of each of these components of the product. So what you want to do is to ensure that the domains are actually living as self-contained entities. They are equipped with the power, they are equipped with all that they need to be able to evolve the domain components over time, and then eventually these domain components need to come back nicely to then distill into the product. So we have to think about how to scale the delivery of the product. I would say, okay, let's try something different. All right. Let's move away from this bottleneck and start creating something that potentially could work, for everyone. I would say, fine, let's create the domains. Now that we know who the domains are and what they do, we have to create the domains and keep them very close to their data sources. And what that meant was also we were able to, provision or apportion data pipelines that allow the domains to work independently. All right. Now, so you can see here that the claims domains can actually go ahead and provision and their claims components and evolve that over time. Multiple iterations, they deliver claims components, version 1, version 2, and so on and so forth. That keeps happening. The same with the policy domain, the same with the location and customer domain and all whatnot. Now, while that sort of independence is a great thing to have, it must also be important that you have a team somewhere that is responsible. And that was why I did mention earlier on in the previous slide that before you build out any product, you need to have a product vision and a product owner, someone who is able to, help these domains, come together nicely and speak a common language. So while domains can actually go away and do their own stuff independently, there has to be a central authority. And I'm very careful by using that word central authority because this is not akin to the loose usage of central authority. One thing we don't want to do in a centralized pipeline architecture is to create an unnecessary bottleneck for the domains. You're going to slow down the entire thing. So you need that central governance authority, and thankfully someone asked a question in terms of what sort of governance frameworks do we put together, to ensure that when we deliver, data products, using this distributed sort of architecture is seamless and easy for us to scale. Now, 3 sort of governance, frameworks or structures you need to create. One is on the domain side. So there has to be a domain governance structure. So each of these domains must have governance structures embedded within them to ensure that the domains are evolving based on set rules or guardrails or patterns defined within those domains. Those domains are free will to define those. All right. Then also importantly, there has to be an infrastructure governance component, to the way these domains evolve, particularly the artifacts. Now you will notice here that I've created this very special, a pseudo domain, so to say. I usually call them the core domain or the enabler, domain. What these guys do, and they are slightly different from the rest of the domain. So typically, when you go to each of these domains, these are SMEs, for example, in location data. These are SMEs in the customer data. The guys in the claims domains are SMEs in the claims data. They understand the claims data in and out. The guys in the policy domain understand the policy data in and out. But the guys in the core domain, typically, they don't tend to have much business context. They are not business SMEs. Most of them will be your typical DevOps engineers, infrastructure automation people. Now, their roles are so critical. What they bring to the table is so critical to ensure that there is uniformity in the way we actually define our pipelines and also roll out or scale our pipelines. I hope that's clear. So, because if there is no standard for creating pipelines, then that means every domain is just, even though living in isolation, but everyone is doing their own things in their own ways. No guardrails, so to say. So, with this sort of control in place, it's quite easy for us to scale out this architecture as best as we can. We can actually, using the power of automation, imagine, this core team is responsible for making out, let's say, baseline Docker images for Airflow, baseline Docker images for, all typical data assets, templates for, orchestrating pipelines, just by the push of a button. And those templates are going to be shared across all the domains. All right. The last thing you want to do is to give the domains the power to go create those baseline artifacts. Now, having said that, that doesn't mean that the domains cannot also have custom templates, within their own domains to be able to enrich and also, add value onto the domain components. They can do that, but there has to be a foundation upon which they can ride upon to do that. So that is what this team, actually provides. So that infrastructure governance component is quite key. All right. And every now and then, before even a domain pipeline is spun up in an environment, the infrastructure governance team have to answer the relevant questions. Are they following the patterns? Has it met this guardrail? Has that been met? Has that been met? Say yes, we spin it up. All right. The new domain pipeline is set up and it's up and running. Okay. Now the final bit of governance structure you want to put in place around the product itself. All right. Because ultimately the product is a mix of all of the domain components. All right. Now these products will evolve over time, and typically they tend to evolve with versions of the domain components. So you can have version 1 to 10 of location. You can have version 20 to 30 of policy. You can have version hundreds of claims. But the product team ultimately needs to ship out the product, and they are the guys who are going to say, guys, for this iteration of this product, we are going to use version 1 of claim. We're going to use version 2 of product, of location. We're going to use version 3 of customer, and so on and so forth. They are ultimately responsible for defining, how the product, evolves. All right. So it's important that you have these three sort of structures in place. Now, this was a definition I did coin a while ago around what a distributed domain, oriented pipeline, architecture is. So, like I said here, it's a pipeline that enables the domains in the data product team to independently build. They have to build their code. They need to test and deploy reusable components. Now, if there is anything you need to leverage in this sort of architecture, is that of reuse as much as you can. You need to limit duplication in this sort of architecture, otherwise you're going to run into problems. Now, and you do that by also specifying a minimum set of shared baseline artifacts. What is most minimum, in the architecture, so that you don't. And having said that, it is also important to realize that the domains are able to contribute to these minimum baselines, but those minimum baselines have to be agreed across board by this governance, team here. All right. So we need to identify what are the minimum baseline artifacts that we need to be able to set up, these different, pipelines. And I can sit down here all day and talk about what minimum, actually means, because it's all driven based on business, definition of business use case to business use case. There is no one single definition that characterizes what a minimum, baseline set of artifacts is. Okay. All right. So a few key principles, when we did that, we could see instant changes, across the pipeline, across the new pipeline architecture. The domains were running on their own, iterating, repeatedly. and the product team was also mixing and matching components or iteration values and shipping our data products, at scale. The governance, forums, we're running regularly to ensure that the guardrails are being followed and so on and so forth. So it really worked, and it got us to a point where the business was quite, robust to even, increase and scale out, the build of the data product. All right, so, but there were key principles that we need to call out here, and of course, like you saw me, call out initially, that the team topology has to be correct. It has to be set, well ahead of time. It's good to have domains, but your domains must be self-contained and isolated. Every domain, must have a clear value it brings, to the evolution or the development of the data products. All right, and there has to be no crisscross in between these domains. So the topology of the team of the domains is very important. Thankfully, Simon also mentioned on that. Now, also include a core or enablement team, across board to ensure that that team is also bringing governance controls. Now, secondly, minimize duplication, and maximize reuse as best as you can. If there are baseline components that could be benefited, across that could be of benefit to all the domains. It is better off building those baseline components at a shared component level, all right, so that the rest of the domains can have the benefit of it, than for you then apportioning, the responsibility to the multiple domains to build out those components. Otherwise, there will be chaos. All right. Now, also, there has to be clear domain regions. Every domain must have clear regions. From the way you also name your assets, your asset nomenclatures. You go to your S3 bucket, for example, there has to be clear boundaries, clear regions. The customer data, sees differently from the, the location data and so on and so forth. Those things are so powerful because then when you do your automations readily rely on the set standards and nomenclatures, to spin up, these products. So it's important that we get, all the conventions right from your buckets, your repositories, and so on, from your artifact repository managers. Those things have to be, well thought out, ahead of time. All right. Effectively, also, there's going to be governance across board. There's going to be governance, arising from this data mesh, construct, but we need to be able to manage it. All right. So one of the good things that data mesh does is that it gives the domains, control to be able to run their own show. But ultimately, you need to create that central authority to ensure that, there is alignment across board. Otherwise, that would be a recipe, for disaster. And then finally, there were so many benefits that this delivered to us. Like I said, it gave us ability to scale, both from a business point of view and also from a tooling point of view. Imagine the ease of spinning up a new pipeline for a new domain. Business, request comes through, we want to set up XYZ number of domains. Quickly, by the push of a button, the pipeline is up and running. The domains are self-contained, they are independent, they are up and running. And also isolation is quite key. Typically in the monolithic, pipeline architecture, when a problem happens, everyone gets, shut down. They stools down for a while. But in this instance, one pipeline architecture, one pipeline for a domain could go down, but also the rest of the domain keeps iterating, their code. So you isolate that failure and have some time to work on it, while the rest of the, product delivery, effort is not shut down. And also for ease of product tracking and metrics, reporting. Sometimes the product timelines might not be readily met. We're not meeting our SLAs, we're not meeting our SLOs. You can actually start tracking based on which domains that are responsible for that. Because typically best practices in the design of your pipeline means that then you are annotating, all your components are, correctly. The basic level of tagging, basic level of tainting, your containers, for example. If there's a problem, you know precisely what domain, that component applies to, and you can then measure performance, as you go. And also for data governance, I cannot emphasize enough about the benefit it brings, in this sort of architecture. And I think those are just some very key benefits, that you can get from here. And this, like I said, was published some time ago in a Medium article, which eventually found its way, into the Towards Data Science, series, and it was picked up as one of those choices in the editorial category. And I think, it was quite an opportunity for me to bear my own mind on the data mesh, conversation and how we're able to bring this to life in our skill. So on that note, I'm just going to take a pause here and see if there are any questions. You guys are beginning to signal me. Yes, if you
Round
hands.
of applause for David for that. That was fantastic. Is that okay? Oh no, we'll go with you first. Yeah. Here we go.
Can you share some details around the data sharing patterns that you've used on how a producer and a consumer shares data? I guess just to expand on that question, say the more traditional scenario would be, if I want to consume data, I would apply for a certain database access, I'll get approved, and then I could query the data from then on. Some other ways could be, source would be exposing a REST API endpoint, for example. But in your use cases, how did you effectively serve a data product? Like in what shape or form did you serve it to the consumers?
So typically via API. So again, good question, because one of the benefits that data mesh brings, about, is you to be able to self-serve all of that data. So we had, models. There were version controls. So every product was version controlled. You can actually go away and populate the data required for that, version based on the schema definition, just by invoking a set of APIs. They already had versions of the domain components, in place. So I have an API endpoint that says, look, I want to build version, one. I want to build version 1 of my product, but this version 1 of my product needs to, merge version 2 of domain, merge version 3 of policy, merge version 4, of address. And you invoke the API, it starts populating all that data set into the product, and it becomes an asset you can ship out, to the consumer.
Thank you.
Yeah. So those contracts have to be defined well ahead of time, the interface contracts. And that's why I keep saying a product owner, a product manager, or someone who knows how the product needs to evolve should be responsible for defining those at the very central level.
With domain-oriented data pipelines, is there a possibility that multiple pipelines are copying same data, or they're processing the same data differently? Or I guess my question basically is about data duplication.
Good question. And I did mention that, if there's anything we want to move away from as best as we can, is that of data duplication. Now, nothing stops the domain from, ab initio, at the very early stage in the pipeline, accessing common data sets. For example, we've had experiences where there has to be a crisscross between a policy data and a claims data at a very early stage of the pipeline, right? But as they evolve the code, as they curate the code for that divergence, starts to happen, all right? So ultimately, they then end up in a publication zone where the baked out, domain data is then purely policy or purely claims, but must not be a mismatch, must not be a crisscross of both. So at the early stage, there could be potential of that happening or possibility of that happening. But as they evolve their code and refine it even to the part of consumption, that clarity will begin to filter in.
If that does happen at the end, does that mean that it was implemented incorrectly?
Yes, absolutely. Yes, there's a problem. And the data quality checks or rules will always pick these things up. One of the things we also tend to do, or one of the things we embedded, again, best practices in building data pipeline architecture is that of lineage. I want to be able to stamp certain records or metadata across the data as it moves from the pipeline. So if a data source is being consumed from the policy domain, and also the claims domain in the publication layer, my quality rules will always run. And when I find some semblance of data in the consumption zone, even though they've accessed the same data from the source, then I'll start asking questions. How come we ended up with the data that is not refined, that is not specific to the domain? How did that land in the publication zone? And that's the data quality issue that we need to address. So data lineage is quite key. As you build out, ensure you are stamping all the useful metadata in the pipeline as you go, because that will come in really handy to measuring quality. Yeah.
Thank you for the talk so far. Look, really interesting. I just had a quick question. Based on that kind of design and that concept that we've just gone through, so it's not concept we've obviously put into practice, but one thing I got from it, I might be wrong here, maybe correct me, is that I kind of look at that and think each of the domains almost need like data engineers within them to create these products, right? So if you're a large organization but don't have enough data engineers, it's kind of like, do you empower the software engineers to actually start taking on some of this responsibility, or do you need data engineers, or does it become like too much of a hurdle to actually not make that leap of faith? That's it.
Yeah, and that's a good question. You know, and this is why I started off by saying there are certain people who reach out to us these days to say, look, I want to build it. That makes an ask. What you really need the mesh, right? You really need it. You know, there are certain things you need to put into consideration before deciding that a data mesh is the right solution for you. It takes maturity. You know, we need to look at, first of all, the use case. Is it the right use case for data mesh? Yes. Now, you didn't have the right level of maturity to deliver that. You know, like you said, every domain is self-contained. You tend to find, DevOps engineers who maintain their own pipelines. You tend to find, the data engineers responsible for getting data in. They just live, in their own. They are well isolated. So if an organization is not robust enough, to be able to set up that sort of structure to support the independence of these domains, then you feel the test have been issued. So you're right. That has to come in. Yeah.
You don't necessarily need data engineers within the company, right? You can hire
Sure.
Data engineers don't necessarily have to know that much about the domain.
Absolutely.
They don't have to. That was it.
From a consultancy. So,
Can I have one more?
we need to apply. Okay, one last one.
Yes.
Sorry, I just wanted to say thank you for your crazy slides. I think everyone was getting excited about your slides, so that was really good.
And that was why I had to apologize, before my talk. It wasn't going to be as pretty as Simon. So thanks for
What's the worst bottleneck to overcome?
The worst bottleneck to overcome in our data mesh?
Yeah.
There's a lot, and when I get into organizations and I look at, I usually try to put in, sort of three sort of lenses. One is the technology side lens, one is the process lens, and one is the people lens. Now, when this whole conversation started in this business, and I gave them the vision in terms of what I was going to do, some people thought I was crazy. Now, this hadn't been done before. Why do you think you can turn this around in this sort of fashion? It took time. So the friction, that comes from the people aspect of it can actually be quite killing if you don't have the right level of executive support. And I think, Kunal did mention this. Good thing I had the support of my EGM at that time, and he said, hey, this vision is great, let's go implement it. And once you have the right people on board at that point, and with the right level of education and also awareness, in a short while, everyone came on board, and it became sort of the holy grail, in that sort of business. So the people side is always very important. Once you're able to get across the people side, ensure you work on the process. This is entirely new. People are going to see it for the first time, and they're going to, perhaps start thinking, how do I deploy my code? How do I mix and match, domain components and all of that? You need to have clear processes for them to follow. Those is I used to wave a very big stick, and I sit in the governance council at the very middle, and I'm watching, who's valuing the patterns. What do we need to do to help them? So bring everyone along, on that journey. It's always very important in this sort of, new conceptual ways of thinking. Yeah.
All right, round of applause for David. Before we leave, who doesn't own a copy of Data Mesh? Put your hands up. And keep your hand up if you've asked a question tonight. Oh.
Who's bought a ticket to Data Eng?
Who's bought a ticket to Data Eng Slides? Oh.
Yeah, did you?
Nice.
Who hasn't bought a ticket to Data Eng Slides and is having remorse about it? No, I'm just trying to make this as awkward as possible. How do we give this book out, Simon?
Ask David. Pick the best question.
What was the best question, David?
Oh, wow.
Now what do I do? They were all good questions.
Okay, who are the three
That was the only correct answer. That was the only correct answer.
It's like 4 people that asked the question, right? So, tough.
Maybe Karen will what are you helping out here? What do you reckon ask the best question?
Yeah, just turn around and throw it like boat paid away.
Probably get one of those injuries or something like that. It's going to be a tough one. So yeah, whoever wants it out of the 4 people that asked the question, maybe just decide quickly.
We don't leave it here. We're going to turn up that.
Yeah, just fight for it.
Are we gonna have a rumble?
Sorry.
Are we gonna have a rumble?
No.
What's the highest? What are those special numbers? They're like 1, 3, 1, 2 Fibonacci numbers. What's the highest Fibonacci number you know? Yeah, one out. One road of data meter. I'm out. Right. I can make this more awkward. Data related question. Who's the keynote for Sydney for Data Expites? And what book did they write?
Fundamentals of data.
Anyone of the 4 questioners know that question?
Fundamentals of data engineering.
And who's the author? So close.
Maybe there was a convenient bit of paper that might have it on.
Yeah, I wonder.
Is it Joe Riggs?
Ooh. But you didn't ask the last question.
Republican data scientist.
Okay. All right. Yeah. Whoever wants it. I've got 5 more books. So come to the conference and you might get one. Thanks everyone. Massive thanks to Thoughtworks and Simon for having us here. Been a really great night of talks and things like that. So probably got about another half an hour of networking and stuff like that. Say hello. Give me a chance to convince you why you should buy a Data Expites ticket, and have a lovely evening. Chat to you next time.
Please take pizza.